Ooh, this is number 20 on the molarity stuff packet. Okay, you can use this to help you through it. And okay, so the question is asking us, what is the molarity of the solution of sodium hydroxide? So our unknown is this concentration. Okay, so if you're trying to solve the molarity of it, what's your favorite equation that you'll be using? The molarity of sodium hydroxide equals the moles of sodium hydroxide over liters of solution. Okay, so let's first scour the information. Scour, scour, scour. Do we have any of that stuff? Yes! What's that represent? Well, Mr. Gorin, that represents the liters of sodium hydroxide solution that you have, right? Okay, so we're already good with that. So what's the only other thing that we need to answer this question? Ding, 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 ding. We need to know the number of moles of sodium hydroxide. Okay, so how the heck do we get that? Okay, well, this unit is not called Solution Stoichiometry for no reason. In fact, it is called that because it has to do with stoichiometry in the solutions land. Okay, so what would your sentence be for this if you were to describe what this balanced equation, the reaction that is happening, what does that really represent? It's saying for every 1 mole of hydrochloric acid, to use that up, it takes 1 mole of sodium hydroxide, and what does that make? That makes 1 mole of sodium chloride and 1 mole of water. Okay, what would happen if I had, say, 25 moles of this, of hydrochloric acid? How many moles of sodium hydroxide would it take to fully use that up? 25 moles, right? Okay, so if we can determine how many moles of hydrochloric acid we have to neutralize, could we then determine how many moles of sodium hydroxide we must have dumped in to neutralize it? Yes, because it's a 1-to-1 ratio. Okay, so how do we know how many moles of hydrochloric acid did we start with? Well, let's see what information we have. We know that we have 0.10 molar solution of hydrochloric acid. It's very important to label all the stuff here because there's lots of different moles of stuff. There's lots of different liters of different solutions. Take the time to do that. It will help you in the long run. Okay? All right, so what are we trying to determine? Well, we were saying that in 0.045 liters of HCl solution, we're trying to determine how many moles of HCl did we have in there. How come? Well, it turns out that there were 0.0045 moles of HCl in there initially. So how many moles of sodium hydroxide over here did we have to dump in to neutralize that solution fully? Well, we needed 0.0045. How come? Because it's a 1-to-1 ratio, okay? Is it always going to be a 1-to-1 ratio? No. What do you have to determine? What do you have to check with to determine whether it's a 1-to-1 ratio? This, okay? You would need the balanced equation, okay? However, here, because it's a 1-to-1 HCl to sodium hydroxide ratio, we know that 0.0045 moles of sodium hydroxide must have been dumped in there. So now, can we get the concentration of the sodium hydroxide solution? Yes, because we know that there must have been 0.0045 moles of sodium hydroxide, and what was the liters? That's 0.0045 moles of sodium hydroxide was dissolved in 0.015 liters of sodium hydroxide. So that should give you the answer, which is 0.0045 divided by 0.015. So I get that the concentration of sodium hydroxide in that initial solution is 0.30 molar. And now you may notice that the answer on the packet says 8.78 grams. What? I don't know. Sorry, but that is the answer. Hopefully that will help you. Please let me know if you have questions. And goodbye.